Good morning. Today we are going to be taking some notes over 8.1, which is right triangle trig. So starting a new unit today. Sorry that I can't be with you, especially after the long week. Hopefully that you have enjoyed your time off. So what we're going to do today is I'm going to give you some notes here. I would encourage you to make sure that you pause your video. That way you can actually work out some examples on your own. Or I might be going a little faster than what we would normally go in class. So it might be beneficial for you to pause the video and then start it up again. The other thing I want to mention is your IA topic submission. Number 2 is due on Monday. I have extended it because of the canceled school. There's really no good reason probably that you should not have that submitted by Monday at 7 a.m. because it was due originally on Wednesday. So that gives you quite a bit of extra time. Something about that I want to mention is that I will be having some one-on-one conversations with you in class. That may not be all of you, but there is going to be some one-on-one where it might be, this is Upton and Mr. Brockman and myself having some conversations with you in class, providing just some live feedback. So consider that as you're submitting your IA topic submission. Again, as I mentioned, the more that you can provide in that, the more research that you have done before submitting that, the better off you're going to be as we move toward the next step of the IA. So just a little info there. So today we're going to be using right triangle trig to evaluate trig functions. We're going to use a calculator to evaluate as well. So make sure you pay attention when we're using a calculator when we're not. So have that calculator handy. And then using right triangle trig to solve word problems. So starting off here, we're just going to start with a right triangle. And remember when we first started on the unit circle, I created a very, very similar right triangle just on a circle. So what we're going to do is we're going to call this point xy. Every point on a coordinate plane can be given the ordered pair xy. And this angle in standard position we're going to call theta. So if we started at the origin and we were trying to figure out the lengths of the sides or how we would name the sides of this triangle, hopefully we recognize that the radius we would call r, so that would be from the origin to the ordered pair. And then horizontally we would move right x units, and then we would move vertically up y units. So again, very, very similar, actually probably the exact thing that we did whenever we started right triangle trig, or we started unit circle trig. So SOHCAHTOA is what we're using. SOHCAHTOA is the acronym that we use to help us whenever we're talking about right triangle trig. So it is called right triangle trig because you have to have a right triangle. We'll be talking about non-right triangles in our next lesson and after that. So as we recall, should remember this hopefully from geometry, but if not, I'm going to go through it. The sine of theta would be the opposite leg over the hypotenuse. So in this case, opposite is y, hypotenuse is r. The cosine of theta would be adjacent leg over hypotenuse, so x over r. And the tangent of theta would be opposite leg over adjacent leg, which is y over x. This should look very familiar because we talked about on the unit circle, sine is y, cosine is x, tangent is y over x. Any point, if it was not a unit circle, we always said that sine is y over r, cosine is x over r, and tangent is y over x. So this is mirroring what we have done in the last couple of units. So we're going to use that as we move forward. First, though, we're going to talk about cofunctions. Cofunctions of complementary angles are equal. That might be something that you want to write down. Cofunctions of complementary angles are equal. So cofunctions will be like sine and cosine, tangent and cotangent. Okay, those are our cofunctions. So if we're talking about the sine of b, so if I come down here and look at b, we know sine is opposite over hypotenuse. So opposite of b would be side b, and the hypotenuse would be across from the right angle, so that's side c. So opposite over hypotenuse for sine would be b over c. Well, if we talk about cosine of A, so if we go up to this top angle, cosine is adjacent. Well, the adjacent leg is side B, and the hypotenuse is still always going to be side C. So we know that A and B are complementary because of those two other non-right angles in a right triangle. All three add up to 180, so take out the right angle, the other two have to add up to 90. So they are complementary. So A and B are complementary. Sine and cosine are cofunctions, and so these two things are equal. The sine of B would have to be equivalent to the cosine of A. So if you think about the sine of A, you could go through opposite over hypotenuse, but hopefully you're going to recognize that the sine of A then is going to be equivalent to the cosine of B. They both have the ratio of A over C. Again, if we're looking at the sine of A, opposite would be A, hypotenuse again is C. If we think about tangent, tangent's cofunction is cotangent. So the tangent of A, again, opposite over adjacent, so that would be A over B, that's going to be equivalent to the cotangent of B. Remember, cotangent is basically, we said it was x over y, tangent is y over x. So that would be the case. And you could go through, and if tangent is opposite over adjacent, then cotangent is adjacent over opposite. So you could look at it that way. So if we're going to find the exact value here, we are trying to find the exact value without a calculator here. So we notice that 8 degrees and 82 degrees, you should notice that these two angles are complementary. Okay, they add up to be 90 degrees. So since they add to be 90 degrees, okay, their cofunctions are going to be equal. So tangent and cotangent are the same, are cofunctions, excuse me. So what we can do is we can say that the tangent of 8 degrees, we can go ahead and change cotangent to tangent. So it has to be equal to the tangent of 8 degrees. Okay, again, because they're cofunctions, okay, and so they would have to be equal. Tangent of 8 and cotangent of 82 have to be equal because they're cofunctions and the two angles add to be 90 degrees. So if we look at those would add up to give us 0, or subtract to give us 0. So we look at, and you could make a triangle out of that. That would make a little more sense. You could come over here, you could make a triangle, a right triangle. You could put 8 degrees, and you could put 82 degrees. Okay, and you could even just make up some letters. Okay, and you could go through and recognize that if we try to make up some ratios, just make things up, A and B, that the tangent of 8 would be A over B, the cotangent of 82 would be A over B, so they have to be equal to each other. Okay. So if we look at cosine squared of 20 degrees plus cosine squared of 70 degrees, again, we should recognize that 20 degrees and 70 degrees, again, add up to 90. So we can start using some cofunctions. So if we think cosine squared, think of something we know its cofunction is sine. So we could change it to sine squared. So we could do some work there. So it doesn't matter, but we could go ahead and change cosine squared to sine squared, and then it would be the complementary angle. So sine squared is 70 degrees plus cosine squared is 70 degrees. So think about that. Sine squared theta plus cosine squared theta. Doesn't matter what theta is, as long as they're the same. Okay, we should recognize that sine squared of something plus cosine squared of that same angle would end up being 1. Now these are some things that you could just type them into your calculator. You would want to make sure that your calculator is in degree mode, and you could just make sure that these work out. Again, this would be on the no calculator part, because you're supposed to understand cofunctions. But you could definitely check your answer with your calculator on your homework. So again, remember that cofunctions of complementary angles are equal in measure. So example 3 here, what we're going to do is we're going to solve this triangle. And to solve a triangle means to find all the missing sides and all the missing angles. So they tell us that side B is 4 and angle B is 10. So this might be a good place where you want to pause the video and draw this picture out as we go through. So what are we missing? We're missing angle A. Remember, angles are always used in capital letters. We know that angle C is 90 degrees. We have a right triangle. We're missing side A, so we use small letters, lowercase letters for sides, and we're missing side C. We also know that C is the hypotenuse, and so it should be the longest side. B is going to be the smallest angle, so side B should be the shortest side. And because A and B are complementary, we know that A is 80 degrees, and so side A should be that middle side. And so what we're going to use is, because we have a right triangle, we're going to use right triangle trig to find all the missing sides of this right triangle. So let's say we want to find A first. We have a 10-degree angle. You could use this complement as well, but I'm going to go ahead and use what was given. We know that side B compares to 10 degrees and that it's opposite. And if I want to find side A, I'm going to call that adjacent. So we have opposite and adjacent, that's tangent. So we're going to say the tangent of our angle, which is 10 degrees, would be opposite, which is 4 divided by adjacent, which is A. Now, we should know how to solve this. We're going to multiply both sides by A. Then we're going to have to divide by the tangent of 10 degrees. You do not have to show this each time. I'm just showing it to you since I'm not here, so you can see what's going on. So we would know that A is going to be 4 divided by the tangent of 10 degrees. We may have to do that in a couple of steps. So you should, again, make sure your calculator is in degree mode. You type that into your calculator, and I'm going to round it to the nearest hundredth. So we get 22.69. Okay. Now, because we have a right triangle, we could use the Pythagorean theorem to find side C. I'm not going to do that because as we round and we round again, we obviously rounded side A. So I'm going to use something that we know. And again, we go back to this 10-degree angle. We know that B is still opposite. And if I want to find side C, we know that's the hypotenuse. So we can use sine because we have opposite over hypotenuse. So the sine of 10 degrees would be 4 over C. Same thing there. You should recognize that C and the sine of 10 are switching. That's what that algebra did on that first one. So 4 divided by the sine of 10 degrees. And so if we type that into our calculator, we get about 23.04. So again, notice that C is the longest side, A is in the middle, and then B is definitely the shortest side by quite a bit. Also, if we did A squared plus B squared equals C squared, we should find an approximately equivalent equation just because we did some rounding. So that's what we would get for our answer if we were solving this right triangle. So we're going to solve this triangle. So another triangle here, we know that side A is 2, so I'm going to mark that, and side B is 3. So we are missing angle A, we're missing angle B, we know angle C is 90 degrees, and we're missing side C, which is the hypotenuse. So how do we find the hypotenuse? Well, since we have two sides here, we would have to use the Pythagorean theorem. So A squared plus B squared would equal C squared. So C could be this positive or negative square root of 13, but C is the length of the side, which the length of the side cannot be negative. We're talking about length here, so it would be the square root of 13. And online it might ask you for a decimal approximation. So then we need to either find A or B. It does not matter because once we find one, we know the other one would be its complement. So I'm just going to find angle A. So what do I know? I know that side A is opposite, side B is adjacent, so I'm going to use tangent. So the tangent of our angle, which is angle A, would be opposite over adjacent. So you want to think, how in the world am I going to solve that? So you should recognize that to find an angle, we have been using inverses. We learned that, how to do that on the unit circle. We learned how to do it finding exact values. You do not have to do that here. You could use your calculator, get a degree mode, and get a decimal approximation for that by typing in inverse tangent of 2/3. And we're just going to go to the nearest tenth of a degree here. You could change these. I didn't change them on the last example, but it would be 33.7 degrees. So A is 33.7 degrees approximately. We know that angle B is its complement, so we subtract from 90 and we get about 56.3 degrees. So that's what we get when we solve that triangle. And again, you can check to make sure that your longest side, again, across from your largest angle, smallest side across from your smallest angle. Just a good check. The next thing you're going to have to do, and we're not going to show an example of this, but you're going to have to solve word problems. So you're going to have to create your own triangle and be able to set up an equation using SOHCAHTOA, right triangle trig, and then solve it. And we're going to talk about things with angle of elevation and angle of depression. So what you have to recognize in both of these cases, you see angle of elevation here when you're looking up, angle of depression here when you're looking down. Okay, what's really, really important here is that you recognize that it's always from the horizontal. Okay, it's nothing to do with the vertical. So here's the horizontal. Okay, you see it here. Also on the angle of depression, this is the horizontal. Okay, so you're never putting an angle on a vertical side. The angle of elevation is line of sight, so that's where you're looking up to the object, or you're looking down to the object, and the horizontal. And so I already drew this one on the right. That's where your angle of elevation goes. So in figure A, angle of elevation is here. We would call that theta. In figure B, the angle of elevation is right there. We would call that theta. If you do not place an angle correctly, then you're not going to be getting the right answers because you haven't placed the correct angle of elevation, angle of depression. So remember, line of sight, horizontal. Okay, that's really, really the key there. The last thing then is, if I give you a picture like this, you should recognize this as a trapezoid. It has one set of parallel sides. You should be able to find all the missing sides. So what is missing? Well, I'm just going to label them. You can label them whatever you want. Okay, this top side would be W. You notice that the entire bottom side is 7. And then we have the two sides. So we call this one Y, and this one over here on the left, maybe call it X. Okay, A, B, C, whatever you want to call it. We know that the height is 2. Okay, that's what we know. So even if I drew this height on the other side, which would make another right triangle, that height would be 2. We also know the exterior angles. On the right-hand side, it's 30. So we know that these make a straight line. So this interior angle would have to be 50. And on the left, it's 140. So this interior angle would have to be 40. We also know from that we have complementary angles. And so we can know that if this one on the right is a 50-degree angle at the base, then up above would have to be 40 degrees. And on the left, if it's 40 at the base, then up above would have to be 50. So a few things that we know there. Now, this is not an isosceles trapezoid, so X and Y are not equal because, again, the angles are not equal at the base. And so we're going to have to do some work to find those. But it doesn't really matter where you start. I'm going to go ahead and try to find X and Y first. So we'll start on the left side here. We'll try to find X. So I'm going to use this angle here. We know 40 degrees. We know that 2 is opposite. We know that X is hypotenuse. So we know that the sine of 40 degrees would equal opposite over hypotenuse. So again, you should be able to solve that on your calculator and find the approximate value for X. So we know that's about 3.11. Doing the same thing on the right side here, 50 degrees. So across from that, this would be opposite. Y would be the hypotenuse. Same type of work here, except for the sine. So Y is approximately 2.6. So the only thing we're missing is W. And we do know two sides of a right triangle, so we could use the Pythagorean theorem to find the third side of those right triangles. We could also just use right triangle trig again to find this third side. I'm going to call the one on the left A and the one on the right B, again, just to have a reference. And so if we're trying to find A, I know opposite and I know adjacent. When we're trying to find B, I know opposite and adjacent, so I'm going to use tangent for each of those. So the tangent of 40 degrees would equal 2 over A on the left, and then the tangent of 50 degrees would equal 2 over B on the right. And so you could go through and solve those. Once you have those solved, then what you would do is you would just subtract that value from 7. And I'm looking at my notes. And I do not have those values. So I'm going to pause it on my end. You can pause it on your end, or actually Laura, you pause, and then we'll come back with those answers. So what we get for A, you should be getting approximately 2.38. And then for B, you should get approximately 1.68. Now, you could also use the 50-degree angle if you wanted to up on the left and the 40-degree angle on the right, and you would just have multiplication. So if we know those two values, what we're going to do is we're going to subtract those two values from 7. And that would give us our approximate value for W, which I'm getting about 2.94. So that is it for section 8.1. Again, right triangle trig. So again, making sure that you can use that right triangle trig to evaluate these trig functions. You're going to have some word problems. And also, you can do those co-functions without your calculator. So your homework is 8.1. I hope you have a great day, and I look forward to seeing you on Monday.